Mike, don't laugh. Okay, as of right now, that's as hard as electricity gets. All right, but it's very, very basic. Now, if I want to find current, I divide both sides by R, right? Simple algebra. So current equals V divided by R. V is what? Divided by resistance, right. Current is voltage divided by resistance. And then if I want to find R, which is, R is divided by the current. Good. So all it is a manipulation of these three variables. This is Ohm's law fully. Okay? This is what's happening.
That's like density, mass, volume.
It's similar, but we're not in chemistry. We're in electricity, which is on the physics side. So stay there with me, okay? It's just three little variables, and we move them around. Now, listen, for those of you that aren't as strong in math, we have the electrician's triangle. This is super basic to understand, okay? And this, when I was in the Air Force becoming an aircraft electrician, this is one of the things that I learned right away. Now, there's more to this that we can add on later, but for our purposes, this is the starting point. This is Ohm's law. So if I cover V, that means I'm trying to find V. What does it tell me is happening? I times R, I is times current times resistance. If I want to find I, which I is, what does I equal? It's literally voltage over resistance, or voltage divided by resistance. And if I want to find resistance, it is voltage over current, which means voltage divided by current. Okay? We can take this to the next step. Voltage, current, resistance, but we can start talking units of measure now. That V stands for what? Volts. The A stands for amperes, and the capital omega stands for ohms. Okay? So if I want to find volts, what do I have to do? Amperage times ohms, right? If I want to find my ohms, my volts divided by my amps. And if I want to find my amperage, volts over ohms, which means my volts divided by the ohms in the circuit, okay? Super basic, but you've got to be able to intermingle the abbreviations for voltage, current, and resistance with the units of measure for volts, amps, and ohms. Are you with me there? Okay. This is something you've got to get straight immediately, or you're going to suffer on the back end when we start dealing with problems. Okay? Because the next step is, after you know how these basics move around, we simply add a few numbers. Okay? That's all. When I quiz you, when I test you, when you do your homework, every number, whether you're finding voltage, current, or resistance, must have the corresponding unit of measure with the number. If you're finding voltage in the problem, there needs to be a capital V after the number. Are you with me? Yeah. If you're finding resistance in the problem, we need to have a capital omega for the ohms. Consequently, if you're finding current, we've got to show the capital A after the number, so that we say this is the amp, okay, or the amperage. Any questions about that? Okay. So, here's very basic for you. Play with this a little bit, just so you make sure you know what goes where, okay? You can do that on your own. Now, the third step is we actually create a circuit and we throw in some numbers. This is a very basic series circuit, and you need to know series and parallel. Okay? I will teach you series first, because series is the easiest to learn. If you don't have this drawn on your paper, go ahead and draw it. Let me tell you the parts so you understand what you're writing. This is the power source, okay? This is power DC, direct current. This is a battery. I don't draw the single line with one short line. I learned a long line, a short line, a long line, a short line. That's a DC power source. This is analog, which is what you're going to be working with in this class. If you take me in digital, and I hope that you do, I will teach you digital power, digital ground, and digital sources, okay, on top of this analog. But if you understand this, you've got a jump start on anybody walking in off the street into DE, which they can. They don't have to be PLTW streams or streaming PLTW like you guys are. Okay, the next symbol that you see is this jagged series of lines here. Does anybody remember what this is when I blew through up there? This is a resistor, okay? This is a resistor. Abbreviation resistor 1. R sub 1 means it's just the first resistor. Then I have another one, R sub 2, that's the second resistor. And then I have another one, R sub 3, simply meaning this is the third resistor in this circuit. Any questions there? Okay. Now what connects the power source to the resistor, and from the resistor to the resistor, all the way back around? This is just a wire. That's all it is. Okay? Yeah? It's a useful current because you're going to learn what's happening. And I'm going to take you through the math so that you understand really what's going on here. And I'm going to introduce Kirchhoff's laws to you as well. Okay? So we're gonna work with the basic, we're gonna work with Ohm's law, and then I'm gonna scaffold you up to understanding Kirchhoff's laws and how they apply. Okay? So the first thing we have, I've got 180 omega. What does that tell you? What does that say mathematically? What does this say to you? 180 ohms, which is the level of resistance. Exactly right. That's perfect. That's perfect. This is a 180 ohm resistor. What resistance is R2? 470 ohms. You don't ever say the resistance is 2,000. It has to be 2,000 ohms. If you say it, that means you're thinking it, which means when you write it, you're going to be consistent, okay? Don't take shortcuts. This is 470 ohms, which is the value of this what? Resistor, okay? Now, here, what is my value of R3? 1,200 ohms. That's exactly right. So you understand 1.2 with the K. What does that K tell you? 1,000. We multiply 1.2 times 1,000. When we add